Welcome to the deep dive. This is where we take the sources you've given us, maybe articles, research, even your own notes, and we really get into them to find the most important takeaways.
Yeah. It's sort of a tailored briefing, really. We help you get up to speed quickly on something fascinating.
And today, we're looking at something pretty fundamental: human potential. Like, what is intelligence, actually?
Right. Is it just one single thing we can measure with a test? Or is it, much broader, much more complex than that?
That's exactly what we're digging into. We've got some key parts of a really influential book here, one that kind of changed the game and how people thought about abilities.
We're going to explore how the idea itself came about, what it actually says about our different kinds of smarts, and what that means for, well, everything from education to just how we think about people.
Our mission here is to unpack all of that for you, highlight the main arguments, the evidence behind them, and the real-world impact.
Exactly. Helping you understand the richness and the diversity of human potential that this source describes.
Okay, so let's dive in. This whole theory, it didn't just appear out of thin air, did it?
No, not at all. It was actually quite deliberate. It started back in 1979, commissioned by a Dutch group, the Bernard van Leer Foundation.
Ah.
Yeah, they funded a project at Harvard called the Project on Human Potential.
And what was the initial goal? What were they asked to do?
Basically to survey the landscape, to pull together what was known about human cognition at the time, drawing from biology, psychology, the behavioral sciences, a real stocktake.
So before this project kicked off, what was the general view? How did science tend to think about intelligence?
Well, you could sort of see two broad approaches. On one hand, you had researchers looking for these universal laws of knowing.
Like the basic operating system of the human mind?
Kind of, yeah. Principles of information processing, how memory works universally, that sort of thing.
And the other approach?
That was focused much more on differences between people. Think of folks like Sir Francis Galton, using statistics to compare individuals, trying to measure abilities, even linking things like family background to achievement.
Okay, and that lineage, that focus on individual differences, that's where the classic intelligence test comes from, right? The IQ test.
Precisely. And the source material we're looking at really spent some time detailing the critiques that had built up around the IQ test by then.
So what were the main criticisms? What did these tests miss, according to this source?
Quite a few things, actually. First, they were often heavily weighted towards people familiar with formal schooling.
People comfortable with paper and pencil tests, sitting still, timed conditions.
Exactly. It wasn't measuring some abstract intelligence as much as a specific kind of performance fostered by schools.
Right.
And linked to that, their ability to predict success was strongest inside the school system.
But less so for life outside school.
Much less so, especially once you factor in things like someone's socioeconomic background, which has a huge impact.
What about the whole heritability debate? How much is genetic? That was a big deal for a while.
Oh, yeah. The source calls it excessive hullabaloo. It acknowledges genetics plays a role, of course, but the really extreme claims, especially linking scores rigidly to race.
Those had been largely debunked.
Pretty much, yes. Complex human skills aren't like simple inherited traits. It's way more complicated, involving lots of genes interacting with the environment.
And the type of knowledge these tests measure.
That's another huge limitation. They mostly tap into what's called crystallized intelligence.
Facts you've learned, vocabulary.
Right. Defining words, knowing historical facts. They're much weaker at measuring fluid intelligence.
Which is more about
Your ability to tackle new problems, to adapt, to learn something completely fresh, problem solving on the fly.
the source has that striking example about brain injury, doesn't it?
It really drives the point home. Someone could damage their frontal lobes crucial for planning and new problem solving, basically gutting their fluid intelligence.
That still score high on an IQ test.
Potentially, yes, if their stored, crystallized knowledge remains intact. It just shows how much that single score can miss.
And it doesn't really tell you about someone's potential to grow or learn more.
Not effectively, no. The source points out they don't capture anything like Vygotsky's idea of the zone of potential development.
That gap between what you can do alone and what you could do with help.
Exactly. Two people might have the same IQ score, but vastly different capacities to learn and develop further.
So the IQ test clearly wasn't capturing the full picture. What about other major figures like Piaget? His work was huge.
Absolutely. Piaget was groundbreaking. He took children's thinking seriously, showed it developed in stages, moving from concrete, hands-on thinking to more abstract, formal reasoning.
Focused on logic, math, How kids understand causality, number,
Yes, very much rooted in that Western scientific and philosophical tradition. His strength was that detailed observation and focus on cognitive structures.
and the weaknesses, according to this source.
Well, maybe suggesting a single fixed pathway of development for everyone, and maybe focusing too narrowly on just that logical mathematical domain, potentially overlooking other kinds of intelligence.
What about that information processing approach you mentioned earlier? Did that offer a broader view?
It made definite progress in understanding specific mental steps, like how memory works, but sometimes it struggled to connect the dots into a bigger picture, linking different kinds of thought.
Or it focused on general problem solving that still felt kind of limited?
Often, yeah. It frequently came back to tasks that looked a lot like logic or math problems, again, maybe not capturing the full range.
So this sets the stage for someone like David Feldman, right? Trying to blend the idea of multiple abilities with development.
Exactly. Feldman helped pave the way by arguing that cognitive skills develop across a range of different domains. Some might be universal, like basic logic.
Things everyone needs.
Pretty much. But others, like reading or map making, are really specific to certain cultures.
And some even more specific, like chess.
Right, or Go. Skills valued only within particular groups or subcultures. This idea of domain-specific abilities really opens the door for a new way of defining intelligence itself.
Okay, so what is the definition proposed in this source material?
It defines an intelligence as, and I'm quoting here, the ability to solve problems or to create products that are valued within one or more cultural settings.
That sounds simple, but it feels like a major shift. What's the key difference?
The valued within one or more cultural settings part. That's huge. It moves away from this idea of a single, fixed, biologically determined thing.
It doesn't say where it comes from, genes or environment.
Nope, doesn't specify the source. And it says nothing about how you test it in a standardized way.
So it focuses on what people can actually do.
What they can do that matters in their world. It immediately tells you we need to look beyond just language and logic, which were the mainstays of traditional tests, and consider a much wider set of human skills.
Okay, this definition emphasizes culture, but the source also looks at biology, right? Does that help pin down where these abilities come from?
It does look at biology, yeah, both genetics and neurobiology. But it's cautious about genetics for these complex skills.
Why is that?
Well, for things like composing music or mastering calculus, it's not like there's one music gene or math gene. These involve tons of genes interacting with each other and the environment in really complex ways.
So trying to find specific genes for broad intelligences is probably too simplistic.
That's the view here, yes. Neurobiology, studying the brain itself, is seen as a bit more promising.
How so? What does the brain tell us?
Ideas like canalization and plasticity are important. Canalization is like the brain being prepared for certain kinds of learning.
Like language acquisition.
Exactly. We seem biologically predisposed to pick it up easily. But plasticity is the brain's ability to change and adapt based on experience.
But that's not limitless, is it?
No, definitely not. The source points out it's constrained by things like timing, critical periods in development, and the specific behavior being learned. That burst of connections in a toddler's brain might be linked to rapid learning then.
So the brain sets up potential pathways, and learning activates them.
Kind of. Basic learning mechanisms seem to work by strengthening or weakening connections that are already there, more or less. The potential is scaffolded by genetics and development, but it's experience and learning that really bring out these latent abilities as functional intelligences.
Okay, so with this broader definition and the biological context, the theory has to be pretty clear about what counts as a separate intelligence and what doesn't. Were there things considered but left out?
Oh, definitely. Part of the process was defining the boundaries. For instance, you might think auditory processing is one skill.
Like just hearing and making sense of sounds.
Right. But studies on people with brain damage show that processing music and processing language often rely on different brain areas. You can lose one without losing the other.
So they don't seem to be a single unified thing.
Exactly. What about something like common sense or intuition? We talk about those all the time.
Yeah, those feel like general abilities.
But are they? When you look closely, social intuition, reading people, seems really different from, say, scientific intuition or artistic intuition.
So they manifest differently in different areas.
The argument is there are probably specific applications of other core intelligences within particular domains, rather than standalone general abilities themselves.
Interesting. Did the source mention any kind of higher level executive function or sense of self that might coordinate these?
It does raise that possibility, some kind of synthesizing ability or executive control that oversees the others. It acknowledges it's a really important and complex question.
But not the main focus initially.
Not initially, no. The first step was establishing these core distinct intelligences. How they all work together in real life is a crucial but sort of secondary question for this stage of the theory.
Got it. Okay, let's get into the specific intelligences proposed. First up, linguistic intelligence. What does that encompass?
It's much more than just vocabulary or grammar. It's a deep sensitivity to language, the nuances of meaning, the rhythm, the sound. Think of poets choosing precisely the right word.
Or someone who picks up languages easily.
That too. It can show up really early, like the example of young Jean-Paul Sartre mimicking adults and writing stories before he was even school-aged.
So it's about mastery of language's potential.
Yes, exactly. The source even uses W.H. Auden's metaphor of a young writer courting language to find their voice. It highlights the skill and deep engagement involved.
How does it map onto the brain? Any interesting findings there?
Well, written language seems to build upon the brain systems for spoken language. Damage affecting speech almost always impacts reading, too.
And culture matters here, too.
Definitely. How your brain organizes for reading can depend on the writing system itself. Phonetic systems, based on sounds, seem to rely more on auditory processing areas.
Whereas systems based on characters or pictures,
Like Chinese characters, they seem to draw more on visual and spatial processing areas. It shows how culture interacts with brain function.
what about the different uses of language, like grammar versus telling a story?
That's a key distinction. The core linguistic machinery, sounds, syntax, basic meanings, seems fairly self-contained in the brain.
But the pragmatic side, using language socially.
That seems neurologically separable. Things like understanding intentions, getting jokes, telling a coherent story, these can be impaired by damage to different brain areas, often the non-dominant hemisphere, even if core language is intact.
So those social aspects might be linked to broader abilities.
Possibly. Maybe systems shared with other primates related more to social understanding than pure language processing. Sensitivity to narrative, for instance, seems tied to this pragmatic function.
And what about people like historians or philosophers who rely heavily on language? Is that their core intelligence?
For them, language is absolutely essential. It's their tool, their medium. But the core of their work might be logical reasoning, or historical analysis, or critical thinking. Language is the vehicle, but not necessarily the engine itself.
Makes sense. Okay, next up, musical intelligence.
Right. This one involves the ability to perceive, discriminate, transform, and express musical forms.
Composers, performers, obviously. What are the core abilities?
Sensitivity to pitch, rhythm, timbre, the emotional power of music, understanding musical structure both locally and across whole pieces.
How does it develop? Is it just innate talent?
Well, the source highlights striking individual differences very early on. Some kids just pick up singing or instruments much more easily, but culture and training play a massive role.
Like the Suzuki method you mentioned earlier.
Exactly. It shows that with the right environment, early start, strong family involvement, peer learning, cultural value placed on it, you can get large numbers of children achieving remarkable fluency. It's not just for a gifted few.
And the examples of cultures with really strong musical traditions.
Yes, groups like the Hungarians, the Enang of Nigeria, Balinese gamelan players. These concentrations of skills strongly suggest that environment and dedicated practice are huge factors, not just genes. High achievement is possible for many.
Music feels so tied to emotion. Does the source discuss the biology of that?
It acknowledges that universal link. It suggests subcortical brain structures involved in emotion and motivation might be key. Damage there can lead to a loss of interest or emotional response to music.
And the right hemisphere again?
Damage there can specifically affect the ability to grasp the overall feeling or emotional tone of a piece, even if someone can still perceive the notes.
Does musical intelligence overlap much with others, like math or language?
People often draw analogies, right?
Mhm.
Music and math, music and poetry. But the source argues the core operations dealing with pitch, rhythm, harmony seem distinct from the core operations of language or logic.
So its relative independence supports it being a separate intelligence?
That's a key part of the argument for its autonomy, yes.
Yeah.
Even if musicians use other skills too.
Okay, let's move to logical mathematical intelligence. Piaget's territory.
Definitely. And the theory builds on his foundation. It sees this intelligence as emerging from interacting with the physical world, manipulating objects.
Start in concrete, then becoming more abstract.
Right, from physical actions to mental operations, then grasping logical necessity, and finally reaching formal operations, reasoning purely with symbols and propositions.
Does language play a role here besides just describing math?
Interestingly, yes.
Hmm.
The source suggests understanding certain really complex sentence structures might actually require kind of symbolic manipulation similar to mathematical thinking, going beyond just linguistic decoding.
What about mathematicians themselves? What's their thinking like?
It references Poincaré wondering why math is hard if it's just logic. Part of it is holding long, complex chains of reasoning in mind.
And the characteristics of mathematically gifted people.
Things like loving abstraction, tackling hard problems, rigor, skepticism, but also speculative freedom. A desire for new, lasting results. Hardy's idea of mathematical immortality.
How are they different from scientists, then? Both use logic and math.
The focus differs. Mathematicians are often creating and exploring consistent abstract worlds and patterns. Scientists use math as a tool to explain the natural world, guided by empirical data.
Like Einstein choosing physics over pure math.
That's the example given, yeah. A different fundamental orientation.
Is this an intelligence that fades faster with age?
The source notes that peak productivity for groundbreaking work in pure math often happens relatively early, maybe in the 20s or 30s. There's speculation about neurological limits on handling extreme complexity over time.
Can it exist in isolation, like someone brilliant at math but not other things?
Absolutely. The classic example is the idiot savant, individuals with significant cognitive impairments overall, but astonishing calculation abilities.
Though often it's more like performing tricks than deep understanding.
Often, yes. They might master algorithms but not be interested in discovery or applying it elsewhere. But true mathematical talent can also exist alongside average abilities, and selective difficulties with math, like dyscalculia, also exist.
What about cultural differences? Is Western logic universal?
This is a big point. Early cross-cultural studies sometimes suggested other cultures lacked formal logic. But when researchers used culturally relevant tasks,
Like the Trobriand Islanders arguing land rights.
exactly, they found incredibly complex chains of reasoning. Examples like Indian mathematics in verse or Islamic number systems show sophisticated logical thought expressed differently. The idea isn't that some cultures are illogical, but that logic operates within cultural frameworks.
And even science has non-rational elements.
Oh, absolutely.
Oh.
All belief systems, including scientific ones, contain elements accepted on faith or tradition. And the very definition of what constitutes math or science has changed dramatically over history and differs even today.
Okay, shifting gears. Spatial intelligence, what's involved here?
It's the capacity to perceive the visual spatial world accurately and to perform transformations on those perceptions. Think sculptors, architects, navigators, chess players.
It's more than just seeing, right? It involves understanding relationships.
Yes, sensing balance, tension, composition in visual art. But also includes metaphoric ability, seeing similarities across different domains, like scientific models using spatial images, the double helix, the solar system atom.
Is visual thinking the primary mode of thought, as some argue?
Arnheim argued that strongly. The source acknowledges that view, but presents a more balanced perspective. Spatial abilities are crucial contributors to many kinds of thinking, including scientific and artistic, but maybe not the sole foundation.
How does it show up in skilled activities like blindfolded chess?
That requires incredible spatial skill, not just memorizing moves, but grasping the game's overall structure, the shape of the positions, mentally manipulating the board.
And artists developing their eye.
Yes, like Hogarth practicing visual memory, or Leonardo advising looking at patterns in walls. It's about training perception and recall. But spatial skill in art goes beyond just copying reality, abstract art, focusing on form and rhythm.
Are there striking cultural examples?
Absolutely amazing ones. The Gikwi Bushmen using subtle tracks to deduce vast amounts of information about animals, knowing their territory intimately.
Or the Puluwat navigators?
Incredible, navigating vast stretches of ocean using stars, waves, wind, color changes, relying on complex mental maps, and finely tuned spatial perception. Often a skill passed down through intense apprenticeship.
How does spatial intelligence compare to logical mathematical?
A key distinction noted is that spatial intelligence often stays more connected to the concrete world of objects and locations, whereas logical mathematical tends towards greater abstraction.
Okay, now bodily kinesthetic intelligence. This is about physical skill.
Yes, but it's twofold. It's using your whole body skillfully for expressive or goal-directed purposes. Think dancers, athletes. And it's using your hands skillfully to work with objects, surgeons, craftspeople, mechanics.
And actors, inventors, often blending it with other things.
Right. The source stresses that almost any real-world role involves a blend of intelligences. You rarely see just one in pure form. Bodily kinesthetic often works with spatial, personal, or linguistic intelligence.
What characterizes skilled physical performance?
It's about translating intention into action smoothly, efficiently. Experts often look like they have more time because their actions are programmed at a higher level, flowing automatically between moments of focused attention.
Is there anything uniquely human about it?
Well, our pronounced handedness or lateralization, one side of the brain controlling fine motor skills, usually the left seems much stronger and more species-wide in humans than other primates. It might be linked to language evolution.
The source mentions an unusual case related to this.
Yes, Joey the mechanical boy, an autistic child fascinated by machines, mimicking their movements. It suggests that this ability to understand and replicate physical actions and systems might have some autonomy, separate from social or emotional understanding.
What about the evolution of tool use?
It was slow and gradual in humans for a very long time. Learning likely involved observation, imitation, maybe gesture, alongside developing brain capacity and things like controlling fire.
And dance is highlighted as a major cultural expression.
Hugely diverse uses: religious ritual, social bonding, artistic expression, storytelling, even healing or military training.
Contrasting examples show different cultural values.
Exactly. Hopi dance emphasizing group unity and tradition versus Samoan dance allowing for individual improvisation and status enhancement. Same core intelligence, different cultural purpose and expression.
And using tools or inventing things, that's often a combo.
Typically, bodily kinesthetic plus spatial. You need the spatial understanding of how mechanisms work, and the bodily skill to manipulate them effectively often involves a feel for the activity.
All right, let's tackle the personal intelligences, intrapersonal and interpersonal. These seem different.
They are. They deal with the internal world and the social world. Historically, you had thinkers like Freud focusing on self-knowledge for managing yourself.
And others emphasizing the social aspect.
Right. People like Mead, Vygotsky, Luria argued, we know ourselves through others. Our sense of self is built in social interaction.
So intrapersonal is?
Access to your own feelings, emotions, being able to discriminate among them, label them, and use that understanding to guide your behavior. Self-awareness, basically. Highly developed in novelists, therapists, wise elders.
And interpersonal.
That's turned outwards. Understanding other people, their moods, intentions, motivations, feelings. Key for therapists, teachers, leaders, anyone good at navigating social situations.
When do these two really merge?
Adolescence is seen as a key time, when understanding yourself and understanding others blend into forming a sense of identity, like Erickson described.
How do you even teach these? They don't seem like academic subjects.
That's a real challenge noted in the source. It's less about facts and more about developing nuanced ways of interpreting situations and feelings. How you construe a situation shapes how you feel about it.
Are there biological roots?
The source mentions things like innate emotional responses, perhaps hinting at biological foundations for recognizing others as individuals and reacting emotionally.
What if someone loses language ability? Does personal intelligence disappear too?
This is fascinating. Neurological evidence suggests they are surprisingly separable. People with severe aphasia can often retain their sense of self, relate to others, and reflect on their situation quite well.
So personal knowledge isn't entirely dependent on language.
It seems to have its own neurological basis, yeah.
And the big one, cultural differences in the very idea of a person.
Absolutely crucial. The Western idea of the independent, atomized individual making free choices is contrasted with many non-Western views, where the person is defined more by their group, relationships, and external forces.
Like the Maori or Dinka examples.
Exactly. So we have to be careful not to impose our specific cultural model of self as universal.
So the overall view is more balanced.
Yeah, the sense of self develops from basic personal awareness, but is profoundly shaped by relationships and cultural interpretation. A mature self integrates both inner awareness and social understanding. The source even questions if the Western focus on individualism creates the appearance of a dominant executive self, which might be partly a cultural construct.
That leads perfectly into how these raw intelligences get shaped by culture and symbols.
Yes, this is the bridge. Potential only becomes functional intelligence when it's engaged with the symbolic systems of a culture, Language, numbers, music, images,
This
gestures.
starts right from infancy.
Immediately.
Yeah.
A baby's actions have meanings interpreted by caregivers within a cultural context.
And preschoolers are mastering all sorts of symbol systems.
Language, drawing, building, singing, pretend play. They're learning how symbols represent the world. Sometimes within one intelligence, sometimes cutting across, like using drawing to represent spatial relations.
Then more formal systems come in.
Right. Literacy, numeracy, the culture's specific notational systems start to channel development much more strongly. Individual expression has to align more with the cultural agenda.
Which might explain why truly radical creativity is less common.
Potentially, yes. Once you're embedded in a system, it's harder to think completely outside it.
And the anthropological perspective reinforces this. Cole's work.
Strongly. It shows that differences in cognitive test performance often reflect different cultural experiences and valued skills, not inherent ability. Change the test to be culturally relevant, and the differences shrink or vanish. Experience matters immensely.
Okay, so how does this apply to the education of intelligences?
Education is key in transmitting cultural values and skills. It happens informally, through observation learning, bodily, spatial, interpersonal skills, just by watching and doing.
Informally.
Through direct instruction, often separated from the context of use. Models, rituals, and of course, schools.
The source compares traditional and modern schools. What were traditional ones like?
Think apprenticeships, highly effective for complex skills, often without literacy. Or religious schools focused on sacred texts, memorization, decoding, strong master-disciple bond, community focus. Surprisingly similar forms across different cultures.
How do modern secular schools contrast?
Broader aims, all knowledge, not just sacred texts, state teachers, earlier start, includes girls, goals tied to citizenship, workforce, personal development.
And the value placed on different intelligences shifts.
Big time. Modern schools often heavily favor linguistic and logical mathematical skills needed for abstract thought and analysis. Interpersonal skills might be less valued than in traditional settings. Spatial and bodily often become extras.
Which can be a challenge for some students.
Yes, especially those moving from more traditional hands-on learning backgrounds into systems focused on abstract symbol manipulation.
Were there critiques of this shift to modern schooling mentioned?
Yes, thinkers like Illich or Frere pointed out potential downsides, loss of integration with community, moral life, devaluing certain ways of knowing.
What about literacy? Is that the key cognitive driver, or is it schooling itself?
An important distinction made, drawing on Cole again. Literacy does foster specific skills related to analyzing language itself. But broad cognitive changes like abstract problem-solving, classification, seem more strongly linked to the experience of schooling overall, not just literacy in isolation.
Literacy plus schooling has a bigger impact.
Seems so, yes. It shapes a wider range of cognitive skills.
Science is also presented as a major force shaping thought.
Yes, both its empirical side, collecting data objectively, and its theoretical side, building explanatory frameworks through reasoning. The key idea highlighted is the openness of the scientific mindset.
Willingness to be proven wrong.
Exactly. Contrasted with closed systems where beliefs are fixed and evidence is sought to confirm them, not challenge them.
Comparing learners from different systems like the Iranian student and Parisian composer illustrates these contrasts.
Perfectly. Different systems cultivate different intelligence profiles, memorization, and interpersonal bonds versus solitary planning and logical analysis via tech. It cautions against seeing the shift to modern systems as simple progress.
So pulling it all together, what are the main applications or implications?
A key point is that the theory isn't an educational goal itself. Society decides the goals. But then MI theory provides a powerful toolkit for how to reach those goals.
By using multiple approaches.
Exactly. Mobilizing different intelligences, presenting information in varied ways, assessing understanding through multiple means, focusing on deep disciplinary understanding rather than just rote facts.
It aligns with calls to develop human potential globally.
Yes, recognizing that potential is dormant until activated by cultural activities and symbolic systems that give abilities meaning and value.
The Suzuki method comes up again as an application.
As a prime example of leveraging multiple factors:
Wow.
biology, early plasticity, interpersonal, mother-child bond, peers, cultural support, though might have costs like de-emphasizing music notation.
Even looking at a nation like Japan.
Their success is framed not just as copying the West, but balancing tradition, imitation, discipline, and education, leading to measurable improvements in potential, linked to factors like nutrition and early experience.
How does this apply to individuals? How would you use MI theory?
It shifts focus to tailoring the means of learning. For the highly talented, maybe intense mentorship or solo exploration. For those struggling, finding ways to use their strengths to bypass weaknesses, prostheses. For most learners, using a wider variety of teaching methods.
Acknowledging resource limits, of course.
Always a practical reality,
The
yes.
source is self-critical too, right? It points out its own limitations.
Yes, importantly so. It reiterates that intelligences aren't just raw processing power. They need cultural engagement to become smart and functional.
And creativity is complex.
It's different from just early novelty. True originality requires deep mastery of a field, and how much it's valued varies culturally.
Metaphor is also tricky to pin down.
Yes. Is it tied to logic? Domain-specific? A general, early developmental stage? The source seems hesitant to call it a full-fledged, separate intelligence in adults.
Okay, so wrapping this all up, what's the single biggest takeaway from this whole deep dive?
I think it's the fundamental shift away from intelligence as one single thing. It's recognizing this diversity of distinct capacities: linguistic, musical, logical, spatial, bodily, personal.
And crucially, that these aren't just fixed biological facts.
Exactly. They are potentials profoundly shaped, nurtured, and given meaning by culture and education. They operate in a context.
How should that change how we think about ourselves and other people?
It really moves us beyond simplistic labels of smart or not smart. It encourages seeing people, including yourself, as having unique profiles of strengths across these different areas, and understanding that how those strengths show up depends a lot on background and context.
And the implications for learning and education today.
It's a big challenge, really. Are our schools, our workplaces, our learning environments set up to cultivate this full spectrum? Or are we still too focused on a narrow band, potentially leaving a lot of talent untapped?
The source definitely suggests that the most effective systems find ways to balance different approaches and acknowledge that cultural context.
Absolutely. It's about finding ways to help diverse individuals flourish using their unique strengths.
This has been incredibly insightful. Exploring intelligence through this lens really does shift your perspective on abilities, learning, and culture.
It's a rich tapestry, isn't it?
Mm.
Understanding these different facets can really change how we see potential everywhere.
Which leaves us with a final thought to ponder, something for you, the listener, to consider. Given this incredible diversity of human intelligences and the powerful role culture and education play, how could we radically rethink our learning environments, schools, homes, communities, workplaces, to truly unlock the full, multifaceted potential that lies within every single person?